Hello everyone. In this video we're going to be simplifying a radical expression. We have the square root of x plus 2 times the square root of x minus 1 plus the square root of x minus 2 times the square root of x minus 1. And x is between 1 and 2 inclusive, and we're going to be simplifying this expression. I'll be presenting two methods, but before I present these two methods, I just want to say a couple things. I was initially planning to do a radical equation for today, but then I changed my mind. You've probably seen, maybe some of you have seen the edit on the community post. But anyways, let's get started. Before we start simplifying this expression, obviously, I do want to show you the graph of this function on this interval. Obviously, we're not talking about the whole thing because this is a radical function as a function. But I just want to show you a graph beforehand so that you'll have an idea what we're going to be working on. All right, great, awesome. So you have a radical expression, but between 1 and 2, it seems to be a horizontal line. Now let's see, and let's find out why this is the case. All right, let's start with the first method. Now for my first method, I'm going to be setting this expression equal to a. You can use any variable. Oopsies, I forgot the 2. So these are conjugates, by the way. I'm going to set it in equal to any variable, doesn't really matter, a, and then I'll square both sides. Now, when you square both sides, you get rid of the radicals, at least some of them. Let's see what happens. So when I square both sides, the first one is basically going to be x plus this, right? Second one, I just want to do a plus b quantity squared as a squared plus b squared plus 2ab. So I want to have the squares first. Doesn't really matter, but it's easier. X minus 2 times the square root of x minus 1, and then finally 2ab, which is 2 times the product of the first and the second terms. And that's going to give us, from difference of two squares, a squared minus b squared. Of course, when you square the radical, you're going to get rid of the radical inside the radical. So 2 times the quantity x minus 1, that is going to cancel out. We'll have x plus x, which is 2x. And then 2 times, let's go ahead and expand this and see what happens. We use distributive property, and we get x squared minus 4x plus 4. This should be familiar to you. And this equals a squared. Awesome. Now, normally we're supposed to square root both sides, but let's simplify this a little bit more, because I do have an interval for x. Hopefully, you know that x must be between 1 and 2 inclusive, so hopefully I can use this to simplify this radical. Notice that inside the radical we have x minus 2 quantity squared, which is nice because that's a perfect square. And now, as you know, the square root of something squared in the real number world is going to be the absolute value of that thing. So we can write this as 2x plus 2 times the quantity absolute value of x minus 2. And that equals a squared. Now consider the fact that x is less than or equal to 2, because remember at the beginning, even though the thumbnail didn't say that, x is between 1 and 2, right? Okay, so x is less than or equal to 2 in other words. Therefore, x minus 2 is going to be a negative or non-positive quantity. So its absolute value is supposed to be its opposite. As you know by the definition of absolute value, this is going to have a negative sign or minus sign. So it's going to be 2x minus 2 times x minus 2 equals a squared. Awesome. Now when we go ahead and distribute this, we're going to end up with something nice. This is going to be 2x minus 2x plus 4 equals a squared. Now notice that a is the sum of two radicals, therefore it is positive. So from here we get a squared equals 4, and a equals 2 is going to be the final result. Great. So that kind of explains why we got a horizontal line when this function was graphed between x equals 1 and x equals 2. So that kind of explains it, doesn't it? Great. So let's go ahead and take a look at the second method now. And I'm pretty sure you guys will find the third method. So for our second method, we are going to do the following. We're going to, instead of setting this equal to something and squaring it, we're basically going to deal with each one separately, okay? So let's rewrite our expression. And now let's deal with each term separately. Now we're going to use a really nice trick here, and this is a trick that's often used, but it's sometimes hard to see. But the presence of square root of x minus 1 being multiplied by 2 should kind of give you a clue. So here's what I'm going to do. I'm going to write the x as x minus 1 plus 1. I hope that's okay for everyone. X minus 1 plus 1, because 1 is going to cancel out, and we're going to end up with x. But that's a good thing to do, because x minus 1 is basically the expression inside the radical without the square, plus 1. So we're going to get that. And then we're going to get the other one. So let's go ahead and deal with this first, simplify it, and then we're going to simplify the other one. All right? So now notice that this is square root of x minus 1 squared. So let's go ahead and write it that way. And we're going to get the following. If we write it that way, I hope this makes sense. We're going to get something like this, square root of x minus 1 plus 1 quantity squared. Awesome. And since we're square rooting it, the result should be, so I can go ahead and write it this way. And the square root of that expression should be the absolute value of the inside. But if you look at the absolute value, you're going to notice that this is a positive quantity, therefore its absolute value is going to equal itself. Awesome. Because square root of x minus 1 is greater than or equal to 0, plus 1 is going to make it greater than 0. So that's the first part, and let's go ahead and simplify this now. But by the same token, you can pretty much say that square root of x minus 2 times the square root of x minus 1 is the square root of x minus 1 minus 2 times the square root of x minus 1 plus 1. And this is going to equal the square root of x minus 1 minus 1 squared, but then you have to square root it. Awesome. Now this becomes the absolute value again, square root of x minus 1 minus 1. And now what are we going to do? We're going to simplify it. But notice that x is between 1 and 2, right? So in other words, x is less than or equal to 2. That means x minus 1 is less than or equal to 1. Square root of x minus 1, given that it's a positive quantity, is also going to be less than or equal to 1. So the square root of x minus 1 minus 1 is going to be less than or equal to 0. So this is kind of like a negative or non-positive quantity. Therefore, its absolute value is going to be its opposite. So we're going to write it with a minus sign on the outside. Awesome. So we got two expressions. Let's go ahead and put those together. I got this one, and I got that one. What am I supposed to do with those? I'm supposed to add those together, because in our expression, remember, they were added, right? These two quantities were added, so I'm supposed to add them. But now they're simplified, so it's easier. So I have square root of x minus 1 plus 1 plus, but that's a negative sign, so let's go ahead and put a minus sign here and write that the second expression in parentheses. Make sure to do that. And this is going to be the answer, right? So let's go ahead and simplify it. Square root of x minus 1 plus 1 minus the square root of x minus 1 plus 1. The radicals cancel out, leaving us with 2 as the final answer. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.